this level, we're just going to do a cursory examination of some organic compounds. Your 120 class may or may not have introduced you to some organic compounds or organic functional groups, but we're going to start getting comfortable with that. I know not everybody in this class eventually goes on to organic chemistry, but it's still valuable to recognize some of these. And for those of you going on to organic chemistry, the sooner you're introduced to these functional groups, the easier you'll have it then. So we're just going to do a very cursory, brief examination of some of the major functional groups. We're not even going to go over all of them. We're just going to look at a few. Okay, so one important functional group is just a hydrocarbon. A hydrocarbon is simple, just carbon and hydrogen, which is why it's a hydrocarbon. Okay, depending on the type of bonds, depends on if it's an ane, an ene, or an ine. Alkanes have all single bonds. Alkenes have at least one double bond, and alkynes have at least one triple bond. Okay, so an alkene, at least one double bond. Alkyne, at least one triple bond. Okay, and alkanes, all single bonds. All right, and then our aromatics, those are going to be the ones that are cyclic in nature that have those double bonds there. So like this one pictured on the slide is benzene. Okay. All right, now within our hydrocarbons, we can have lots of different isomers. So same structural formula, or same formula, but different structural arrangement. So all three of these have the same number of carbons and the same number of hydrogens, but they're linked different. So these are isomers. We can get isomers even beyond hydrocarbons. Like there's isomers of compounds that have an oxygen in them and things like that. Later on this semester, when we look at structure and shape, and we do a lab on that, there will be a section where you'll actually have to draw some isomers. Okay, and so here are a few different hydrocarbons: methane, propane, butane. The beginning of it has to do with how many carbons. So if you see here, I've got ethane, or I don't have ethane, but I have ethene and ethyne. Ethane would be the one with a single bond. Okay, and then we've got some of the common uses for those. So we see these a lot. Propane, that's what you get your tanks filled with if you've got like gas grills or things like that. Okay, and so there's all those prefixes. So meth is 1 carbon, eth is 2 carbons, prop is 3 carbons, but is 4 carbons, and then it just goes on down the line. Okay, alcohols. So what we get in alcohols is we have an OH. Okay, so there's my alcohol, there's my alcohol. So this is my alcohol. Okay, so there's my alcohol functional groups. Okay, so I have 2 carbons with that alcohol, so this is ethanol. Here I have 1 carbon with the alcohol functional group, so this is methanol. Okay, so you can see where we still use those prefixes there for the number of carbons. Okay, so we got that alcohol functional group. Okay, all right. Ethers, okay, what we'll see with an ether is we've got a carbon, oxygen, carbon. Okay, so the carbon, oxygen, carbon, that's your functional group. So I have 1 carbon on either side here. So this is dimethyl ether. This is diethyl. If I was doing the carbon framework, I would draw diethyl ether like this. It looks like a little bat, which is fun to draw around Halloween time. When we do these Every end and bend is a carbon with the maximum number of hydrogens around it. So here I'd have, they're just quicker to draw with the carbon framework structure. Okay, so again, we'd get that. This one would just be like that. Okay. So that's your ether. Ether used to be used as an anesthetic. So if you hear just ether and it's not designated if it's dimethyl ether or diethyl ether or etc., if it's just ether, it's the diethyl ether, and that's what they used to use. They would put it over people's faces and use it as an anesthetic years and years ago before we had modern anesthetics. If you ever work with ether in an organic lab, you have to be really careful not to inhale it. I was doing a lab one time as a student, and I was really good in lab. I was a chem major, and some of my classmates kept coming up to me and putting like, hey, does your reaction look like this? Hey, does your reaction look like this? Hey, does your reaction look like this? So I kept having beakers shoved in my face, and we were working with ether that day. Oh my goodness, I inhaled so much ether, and I left class when I was done, and I never should have driven, but I wasn't really aware that I had inhaled so much ether because I was like super boring. I never did anything as a student, so I had never tried anything. And I went to work, and at the time I was working as a lab tech at a high school, and I got to work, and oh my goodness, I was like floating. I was put in a corner and told, you're not prepping any labs, you can sit there, and just, yeah. And this was the high school I had gone to as a student too. So all the teachers knew me, and they're like, what is up with you? I'm like, well, we were doing this lab. And they're like, oh man, okay, yeah, you get to sit in a corner of a classroom and do nothing for your shift today. So be wary of ether. All right, and then we've got carboxylic acid. So I mentioned these briefly before. So this, the COOH, okay, and you can see highlighted in red the carboxylic acid group in each one of these. So that is the carboxylic acid functional group. That's why in acetic acid, when I write it, I like to write it as CH3COOH because that gives me structural information about that carboxylic acid group. If you write it as the C2H3O2H, it doesn't really give you that clue that you're dealing with a carboxylic acid. So most chemists I know do like to write the carboxylic acids with that COOH because it reminds you that, oh yeah, you're dealing with a carboxylic acid. Okay, and you can see like methanoic acid, formic acid, 1 carbon. Acetic acid is also known as ethanoic acid. Oh, there's 2 carbons there. Butyric acid is also known as butanoic acid because 1, 2, 3, 4 carbons there. So there's where we come back to those prefixes that we looked at with our hydrocarbons. So they keep coming up. All right, and then here is just a sampling of some of the other functional groups that you'll see. If you see R and R prime, that's just saying that this functional group is in the middle of stuff with, you know, other carbons or other things on the sides of them. Or if you see like, you know, RCOH, that R could be anything. It could be a 2 carbon chain, a 3 carbon chain, whatever. So the R is just representative of this functional group is hooked to something. When you see R and R prime, that's indicative that this functional group is hooked to something on one side and hooked to something different on the other side. Okay, so that's what the R means. And so you can see there's the general formulas with the R's, and then we give you some examples on there. And so the ones that I went over here were the alcohols, the ethers, the carboxylic acids, and then of course our hydrocarbons. But there's also aldehydes and ketones and esters and amines. For this class, I want you to start recognizing the hydrocarbons, so the alkanes, the alkenes, and the alkynes. I want you to start recognizing the alcohols, the ethers, and the carboxylic acids, okay? I'm showing you the rest of these so that you know that there's more functional groups coming down the line, but for the purposes of this class, the 4 that I went over here, hydrocarbons, alcohols, ethers, and carboxylic acids. Those are the 4 that I want you to start getting comfortable with and starting to recognize, because those are the ones that I could be like, hey, here's a molecule. What functional groups are here? And those are the 4 functional groups that I'm looking for this class. Okay, so that's our brief introduction to some organic compounds, some common ones that you encounter frequently. All right, okay, that ends our chapter 3.